we are going to talk about the three states of matter, solid, liquid, gas, and we're going to discuss the properties they have that make them unique and different than one another and some ways we might identify them. So here we have our solid, and we can see that even though these molecules are in a solid shape, like right, my table is very hard, they are actually, if you look at them, they are still moving. They are vibrating. These molecules vibrate. They're just moving so, like, it's such a little vibration, we can't see it. And right, molecules are teeny tiny, we can't see them with our eyes, but they're actually moving, so they vibrate. And their speed is very slow. They vibrate, and it's slow, like they're just barely moving back and forth here. So that means that they actually have a very low kinetic energy. So that word kinetic means to move. How do they move? They move at a very low energy, right? They're like, oh, very sluggish, and like they just don't have a lot of energy. They're still moving. They have some energy, it's just very low. It's like a very drained battery. Their battery's very low, so can barely do anything. And that is because they are at a very cold temperature. So they have lost their heat. Their heat has been given away, and now they're cold, so they want to pack in together, they want to huddle up, and they're cold, so they're shaking. So that means, right, because they're cold, they interact with each other by packing together. They want to bunch in and be with each other. And due to that, right, they pack in, they have a very fixed shape. That shape is set. And they pack in, and they make themselves very dense. So these are high density, or you might call them more dense. The density describes how packed together are the molecules, right? These are more packed in, so it's denser. So most likely if you drop something like a wooden ball inside of liquid, right, it's going to go down. A metal ball goes down. Something heavy, it's packed in there, it's going to sink down. It's going to go low into them. So it has a very high density because they're packed in tight. So their volume is what we can measure. So these have a fixed volume because we can measure that this is 3 inches, this goes back 2 inches, it goes up 4 inches, or whatever it is. We can measure how much space they physically take up. And because of that, I'm going to call this a definite volume. So it's set and we can identify it. When things are definite, it's for sure. And that definite volume also has a definite shape. We know the shape of it. I can see that, right, a cup looks like a cup. My table looks like a table. My chair looks like a chair. It has that shape and I can measure the dimensions of it. So now let's talk about a liquid. So liquids, we can see they flow. They're just kind of moving, and they move at a medium speed. So not super fast, not super slow. They're just, right, they go with the flow. So they have a medium kinetic energy. They're moving, and they're going. And if you look, sometimes we can even see how they move around. And they have a temperature that's just kind of in the middle. So again, right, they're not frozen, so they're above 32 degrees, but they're less than the gases, so below, things boil up. Oh, is that 220 degrees Fahrenheit or 100 degrees Celsius? So again, these have a medium temperature. They're not frozen and they're not boiling and hot. And the way they interact with each other is they're just, right, they go with the flow, is they slip and slide past each other. So they just slide past. When they bump into one, they just brush against it and move on where they're trying to go. And their volume. We can. So if this cup of water here, I can measure how much water is in here. I can see it goes up to here, and I can measure that, or how many milliliters that is. So it does have a definite volume, but it does not, no definite shape, right? If I take this water, it can move and I can make it look like that. I can make it look like that. If I pour it in something different, it's going to take on a different shape. So it does not have a set shape, but I can see how much is inside of here. I can measure and say, oh, I have 300 milliliters of water, or 5 cups, or whatever, however you're measuring. So then our gas molecules are moving, they want to escape, right? So they are moving and they are pushing. So they push out and up. So they go out and up. And, oh, I forgot density on this one. So let's talk about their density. So again, right, they have a medium density because they're not super packed and they're not really spread out. So they just kind of are in the middle there. Lots of, right, everything about the liquid was in the middle, is medium. Okay, so back to our gases. So these gases want to go up and out. They're trying to escape. And as they're doing that, they move quickly. The hotter they are, the quicker they're going to move. So these have a very high kinetic energy. You might think, I don't know if you guys have ever seen the Energizer Bunny commercials, right? It goes, 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 and it can just keep on going forever because, right, they're so pumped up. They have this high energy. And that is because they are heated up. They have a higher temperature. They're going to be hotter. That's what made them start to move. Like if you're an athlete, you want to warm up first, right? Swimmers don't just like hop in the pool and go. You can see, watch the Olympics, right? Like they're like slapping themselves or trying to get those molecules heated up and moving so that their muscles are ready to go. So they have that hot temperature, and the way these interact with each other is they want to, again, right, get away from each other. So they want to get away and spread out. They're pushing out and away from each other. So their density is, they have a very low density, or these are the least dense materials because they've spread themselves out. They're spread out from each other. So that's why like it can kind of float. If you think of a helium balloon, right? They're going, that's why it can float as opposed to a regular balloon that just sits on the ground. It has molecules that are pushing out and making it less dense so it can float. So things that float are less dense. Things that sink are more dense. So as for a gas's shape, it has no definite shape. If you're not containing them, they're just going to spread out and go everywhere, and you're not going to be able to keep track of them. They're gone. There's no set shape to them, which means that they have no definite volume. It's pretty hard to measure how much you have when they've all escaped. So they don't really have a set shape or measurement. They're going super fast, and they're wanting to go up, get away from each other. These ones here, just flowing, medium, everything is medium. I can measure how much there is, but their shape can change. And these ones, I know how much there is, I know what they look like, I know they're packed together, and they're going to sink down because they're all tight in there, vibrating away. So you're going to use this information to fill out each of these pages here. So you're going to decide which word goes under here. They might not all have exactly the same amount. Which of these words or pictures matches here? Think about, we've got helium balloon here and regular oxygen here. So what words are going to help describe a balloon that goes up versus a balloon that if I just blow it up, falls to the ground? And then you're going to draw and model a solid, a liquid, and a gas molecule here. You've got these pictures here that can kind of help us think about what are each of the molecules doing. So use this information to fill out all of your slides.